Okay, now I'm going to introduce you to a very useful tool that will help us find the trig values for angles that are multiples of our special angles. So angles that are multiples of 30 degrees, 45 degrees, 60 degrees, or quadrantal angles. And this is called the unit circle. You'll be using the unit circle a lot. There's actually one on your formula sheet. Okay, and let's just look at, so the unit circle is centered at the origin at 0, 0, and it has a radius of 1. And along this unit circle, in every quadrant, you've got a multiple of 30 degrees, 45 degrees, and 60 degrees, okay? So here we have 30, 45, 60, and then 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, and 330. And you'll notice that the ones in red here are the ones that are multiples of 45 degrees, right? They're the ones that kind of cut each of the quadrants in half. And the ones that are in blue here are the ones that are multiples of 30 degrees and go all the way around. And we can use this to help us find, like I said, the trig values. So let's just look at 30 degrees. If we look at 30 degrees and where it intersects the circle, and we're going to draw a line perpendicular down to the x-axis so that we have a right triangle. Okay, and let me draw that triangle over here just so you can see it, all the other stuff. So we're saying this is 30 degrees. This is a right angle. The hypotenuse here is actually a radius of the circle. So that's 1 since it's a unit circle. Now this gives the x and the y coordinates. So the x is how far we've gone to the right. So that would be this value right here. So that would be square root of 3 over 2. And the y value is how far up we've gone. So here, if we want, say, sine of 30 degrees, we're going to take the opposite, which would be the y coordinate here, over the hypotenuse, which is always 1. So we would just take the y coordinate, which is 1/2. And before we've seen that sine of 30 degrees is 1/2. Now in general, if you drew a right triangle for any of these angles, the hypotenuse would always be 1. So when we want to take opposite over hypotenuse, it would be opposite over 1, which will just be the opposite, which will always be the y value. So what this is telling us, that if we're looking at the unit circle, if we find an angle, that sine is always the y coordinate of that point that's labeled. Cosine would be the adjacent, the adjacent over the hypotenuse, which will always be the x coordinate. Tangent would be opposite over adjacent, so that's going to be the x over the y. And then if you flip all of those for the reciprocals, cosecant will be 1 over the y. Secant will be 1 over the x, and cotangent will be x over y. So we can actually use this unit circle to really quickly find sine and cosine of these angles. So for example here, if we want to look at pi over 6 and we want sine of that angle, we're going to go to pi over 6 like we just did with 30 degrees, and we're going to take the y coordinate, which is just 1/2. Cosine will be the x, square root of 3 over 2. And tangent will be 1/2 over square root of 3 over 2. Which, remember, when you're dividing fractions, take the top one, multiply by the reciprocal. So we'd get 1 over square root of 3, which we can rationalize to be square root of 3 over 3. Okay, for cosecant, we want 1 over the y, or you can think of flipping the sign. So that'd be 2 over 1, which is just 2. Secant will be 2 over the square root of 3, which when we rationalize will be 2 square root of 3 over 3. And cotangent, so before we rationalize, tangent was 1 over square root of 3, so cotangent would be square root of 3 over 1. Or just square root of 3. Okay, so we can now use our unit circle for any of these angles. The sine is the y, and the cosine is the x value.